If you think about how we interact with media, with our cellular phones, if we think, I'm sure Andy Baer, when he gets up here and talks about what's going on at Comcast, when you think about how in our homes media is transforming, or the delivery of media is transforming how we view movies, how we listen to music, big data is all around us. It's around us in the federal government, in surveillance, homeland security, customs and border protection. It's around us in the life sciences space for medical research. It's around us in how we consume media. It's around us in how technology companies design chips. Everywhere you look, there's big data. Think about this from a numbers perspective. There was a study that IDC did at the beginning of this year. IDC is a big technology research firm. And the study's called the Digital Universe Decade. And one of the key takeaways from that study was that in 2020, the world is going to be dealing with 35 zettabytes of data. We talked about petabytes earlier. How many people here know what a zettabyte is? Okay, just a few. Maybe we should go into a bit of storage geek history lesson here. We all know what gigabytes are. We all know what terabytes are because you can go to the store and you can buy a terabyte drive at Best Buy. Once you get past terabytes, let me put it in context for you. Somebody brought up the Library of Congress earlier. The entire printed contents of the Library of Congress is only about 20 terabytes of storage. 1,000 terabytes equals a petabyte. We, as a company, are a minute fraction of the storage industry, less than 1%. And yet we sell about a petabyte of storage every single day. Every single day. If you get to 1,000 petabytes, you get to an exabyte. If you think about exabytes, 800 exabytes, that's how much data exists in the world today. And then 1,000 of those is a zettabyte. And so think about that, 35 zettabytes of data in 2020. Over a 10-year period, we're going to see data increase 44-fold. And you might be asking yourself, well, why does data grow that big? Why does all that data exist? And I think that the answer to that question comes back to innovation. One of the things that I've realized in being a company that I'd like to think is very innovative is that innovation is something that causes people to strive for the next great breakthrough, the next breakthrough. And as you strive for those breakthroughs, you end up consuming all of the technology around you. You end up consuming and reaching the bounds of everything that is around you to give you that innovation. So as companies innovate, as research organizations and governments innovate, they leverage the best and the biggest computers out there. They leverage the maximum amount of storage capacity that could be created. They leverage the bounds of science. They leverage all of the combined technologies that they can bring to bear to solve a problem. And so the reason this big data, this 35 zettabytes, is going to exist in the next 10 years is because innovation is going to drive new ways of working with data and leveraging data to solve problems. The big problem that all of us as IT professionals in this room are going to have is that while the data is going to increase from 800 exabytes to 35 zettabytes 44 times, the number of IT professionals available to manage that data growth, it's only going to be about 1.4 times. So there's a gap there. There's a huge gap. And that gap is very prevalent. It was another study this week, actually, that Gartner Group made. And the Gartner Group study was focused on 1,000 CIOs, big companies across 8 countries. And they asked a simple question. What is the biggest area of challenge for you over the course of the next 5 years? Number 1, almost 50% of respondents said it's the data growth. Number 2 was scale and performance, which I'd argue is somewhat related to big data. And then number 3 was really around how you go and create an infrastructure that allows agility, that enables you to go and scale that infrastructure and manage this growth, even though there's going to be very little growth in IT personnel. That's going to be a significant challenge that everyone here is going to have to deal with and is going to have to solve. One of the major technology trends that's occurring today to help to deal with this big data wave is a really revolutionary change within enterprise data centers. How many of you have heard of cloud computing? A lot of hands. How many of you think that if you asked your neighbor what cloud computing was, that they'd give you the same definition that you think it is? Everyone's shaking their heads. Cloud computing, virtualized data centers, data center 2.0, private clouds, enterprise clouds. There's a whole lot of names out there. On-demand IT, the name of this session, that's another name for what I'm trying to describe as a revolutionary step in the data center. The data center of tomorrow is going to have to take tasks that humans are doing today, and it's going to have to automate them so that we can deal with this huge tidal wave of big data, so that we can deal with the compute power that comes with that tidal wave of big data, so that we can deal with the amount of networking bandwidth that we'll need to service applications that are trying to leverage this huge wave of big data. And in each of those 3 layers of the data center, there's a significant amount of innovation. The 3 layers of the data center, if you think about it, servers, which is compute, networking, and storage, together create a platform. And it's a platform for applications to be delivered on. And if you went back through history, that application platform has evolved a great deal. If you went back to the days of the VAX, Digital created an operating system, VMS, which was a tremendous multitasking operating system that enabled you to create a flexible application deployment platform. That innovation gave way to multiprocessor Unix servers. Those servers got bigger and bigger. We moved into a world of industry standard servers where you have racks full of 1U and 2U servers. And now we have a new wave with technologies like virtualization that are going and taking that flexible compute resource and leveraging it in ways that we haven't been able to leverage before. And so what is virtualization all about? We hear about it a lot, but fundamentally, virtualization is really disaggregating the operating system from the VMS days, from the Unix days. It's taking compute power that's in separate physical boxes and combining them together to help you create a flexible utility to deliver applications on. And that compute utility is probably the furthest evolved out of those 3 layers of the data center today. It's actually an area where there is a lot of innovation and where we're seeing a tremendous amount of early deployments within enterprises today. The networking layer is probably the second most evolved part of this infrastructure. The networking layer not only needs to get faster, but we need to be able to create the agility to reconfigure networks on the fly to deal with the fact that applications in a virtualized world are going to move from physical server to physical server. They're going to move around. They're going to have to enable that agility across both the world of physical switching, physical routing, and virtual switching as well, which is a new paradigm in the data center that really is changing how networking professionals think about management. So if we solve those 2 challenges, then there'll be a third challenge. The challenge will be, how do you scale storage to deal with this huge tidal wave of big data? How do you enable enterprises to manage storage as one giant utility? That's a challenge that we're tackling. It's also a challenge that almost every big company on earth who sells storage is trying to tackle. And the problem fundamentally is that we've gone from a world where we've disaggregated large systems, mainframes, mini computers, Unix servers, down to these small components, and now we need smart software to make those components operate well as a single unit. Virtualization does that for computing power. That smart software is really at its infancy in the storage layer, and it's really going to be necessary. The problem, whenever somebody asks me, what's the problem that Isilon solves? Isilon solves a management problem.